So I'll finish this up. I was walking around. I think that we got some good answers. And then my ln t's will cancel, right? And I'll get t equals ln of 0.5 divided by negative 0.2. And I think it was 3 point something, right? Ln 0.5 divided by negative 0.02. Whoop. Try to do it fast. Ln 0.5 divided by negative 0.2. Okay, so 3.466, I think, days, or no, years. Years. Okay, if you got that, give yourself a pat on the back. That's great. Okay, let's keep going. I know I'm kind of loading you today, but that means tomorrow we should have like a nice work class tomorrow. There's a few things we got to do before the test for you to be comfortable and ready. Because like I said, this is a pretty heavy unit. Have you found it a pretty dense unit? Like, there's lots going on in this one, right? All those different types of equations and then the word problems themselves. So how much would you have to invest initially if you want to have $5,000 after 10 years in an investment with an annual rate of 6.5 compounded monthly? Use the compound interest formula. So we saw this at the very beginning of this unit. I think assignment 1 referred to compound interest. You will be given it in your test and on the exam, but you have to know what all these mean, right? So what are all the variables we have? We have A and P. The 1 is a number, so I don't worry about that. I've got R, and I've got T, but I also have this N, right? A and P mean the same as they always did, except because we're talking about money, we can use IBI's terms. They would make a little more sense, like the initial value, present value, final value, right? So present value, final value. Or you can just think of its present amount, final amount, like we did before. R is the rate, right? Now, when we're talking about money, we usually talk about the rate is called the interest rate. It's the rate of growth, but it's usually referred to as, by people in finance, interest rate. Now, the only thing about compound interest, or anytime we're talking about money, time is, T is time again, but this is the one case, it's not like the natural growth one, time is always in years for compound interest. Because that's the way the banks have set themselves up. The financial industry deals in, they have to quote annual interest rates, that's what this word means. So because it's an annual interest rate, time is understood to be in years. The only thing we haven't talked about is N, and N is the number of times the money is compounded. Per year. Now, again, that's my money symbol. It doesn't look very good. Again, this is something that financial institutions have to tell you. When you're putting money in the bank or you're taking money out of the bank, they have to tell you, and it should be in all your contracts that you sign, what their interest rate is, the annual interest rate, and how many times they compound. Now, what compounding means is how often your interest is calculated. So when you put your money in your savings account, if they do daily compounding, every day a cent or half a cent will be added to your bank account. It's not a lot. So the more often they compound, the more interest grows. So think about that. If you have money in the bank, you want your interest to grow, right? But if you borrow money, you don't want your interest to grow. So more compounding is good if you have money in the bank, less compounding is good if you owe them money. Because if you borrow money, they also have to tell you the interest rate they're charging you and how often they're compounding. Okay? So this is a very strange, it's only in the world of finance, But how we figure out what n is, because that could be hard for students, look for the word compound in the problem. So here's my word compound, right? Look for the word compounded. And right after the word compound is another word. That's your n value. Okay? Now, it doesn't give you a number, but remember, it's how many times per year. So, like, if my money was compounded monthly, what would n be equal to? 12. Yeah. You're tired, eh, Adam? Yeah. Okay, so let's, for our question, let's record all this. So n is 12. And on the board, I think one day I put lots of n values. I'll give you those tomorrow, maybe. I'll give you more n values. What if I said my checking account gave me interest compounded daily? What would n be? 365, right? So there's 365 days in a year. Okay, what do we have here? We have, if I want to, how much would I have to invest initially if I want $5,000 in 10 years? So is the 5,000 an A or a P? It's the A value, yeah. Okay, so that means I don't know P. That's what I'm looking for. The interest rate is 6.5%, but I don't use percent numbers. They're not calculator friendly, so that's 0.065. Agreed? Just divide by 100 to get the right decimal number. And time is 10. Now, it has to be in years, right? And this fortunately for me, the question gave it to me in years. If they said 6 months, my t value would be 0.5, right? Half of a year. All right, so now I have to put everything into this formula. So 5,000 equals P bracket 1 plus 0.065 divided by 12 bracket 12 times 10, which is 120. Okay? Now, let's see if I can, this is a terrible one to punch into your calculator, right? But we can do it. Let's see if this can neaten up nice. I don't think it's going to neaten up. Let me just see if I can clean the brackets up at all. What's 0.065 divided by 12? No, that doesn't work out nice, does it? Okay. So unfortunately, the only thing I could do is probably call that 120, right? I want to solve for P, right? How would I do that? How do I get P by himself? Yeah, but our calculators can handle it. So it's 5,000 divided by 1 plus 0.065 over 12. Notice how I can't, and the only thing I'll do is I'll call this 120, right? Notice how I didn't round here, because I've mentioned numerous times in this course, the only time you can round in mathematics is when you actually use your calculator, right? The very last step. You can't round here and then again, because your answer will be off. I know things are different in science, but in math we only round once at the end. You might get the same answer this time, but you won't 100% of the time. They set the exam up so that the only time you could get no, not with rounding. You can't do it, because they'll set it up to trick you. So 5,000, but you guys all have good scientific calculators, so it'll work. Just bracket 1 plus 0.065 divide 12, close bracket, exponent 120. Wasn't that hard, right? Okay, now this is where we deviate. For pre-cal, the default is 3 decimal places, unless you're told others, except for money, because in Canada we use 2 decimals. So money is always 2 decimals. So this will be $2,614.81. 2614.81. And I would suggest to you, when you're studying, either tonight, tomorrow, this weekend, even though some of you I know aren't doing the calculator work with me, and many of you are, which is good, but I would actually pick your calculator up and make sure that you're getting these numbers, because as we all know, for this unit especially, it's not the setup, it's not the isolating for x, it's the calculator that we can get wrong answers with, right? It's such a heavy, the formulas are so dense that it's difficult to get right answers, even if you have the setup. So make sure you know how to put this into your calculator and get this number. Okay, let's try a log one now. Are we okay with this? Okay, we're going to try a log question now. So it says, given the pH, this is how they calculate the pH of a substance. pH is equal to minus the log of H plus, and what that is, it's the concentration of hydrogen ion in the substance. So the pH is equal to the negative log of the hydrogen ion concentration. A lake affected by acid rain has a pH of 4.4. A person suffering from heartburn has a stomach acid pH of 1.2. How many times greater is the hydrogen ion concentration of the stomach than of the lake? Express your answer as a whole number. Okay, let's step back a sec. So pH is just how much hydrogen is in a substance, basically, right? They've given us the formula on how to calculate pH. I'm just going to record it again here, just so I have it in front of me. Okay. So we've got two substances that we're studying. Acid rain, which is very bad, right? It's because of pollution. So all the chemicals that we use in our soils sucked up into the atmosphere and then rain down on us. So they say it has a pH of 4.4. And inside our stomach, we have a lot of acid too, right? To basically destroy the food that we eat, right? Compact it and disintegrate it. So it's really acidy too. But acid rain is more acidic, right? Isn't it, than pH? Or is it less? How many times greater is, or the stomach acid than the lake? The stomach acid, of course, is more acid than the lake. Otherwise, you'd burn if you jumped into the lake, probably, right? If it was that acidy. Okay, so let's figure out what we have here. So let's do acid rain. Let's see what we got here. Acid rain has pH of 4.4. So let's do this. So the acid rain has a pH of 4.4. It says how many times greater is the hydrogen ion concentration. So I'm trying to figure out what this is, right? But I have to compare it to the stomach acid too. So how would I isolate this guy? Any idea what I can do to compare this? Like, what if I put it into exponential form? Can we put it into exponential form? Would that help us? Let's see. I think I'm going to get rid of this negative sign first. So if I divide through by negative, I get negative 4.4 equals log of the hydrogen ion concentration, right? Now, pH is a base 10 scale, right? That's my base here. So what if I did this? 10 to the negative 4.4 is the hydrogen ion concentration of acid rain, isn't it? Yeah? So this is the acid rain hydrogen ion concentration. 10 to the negative 4.4. All right. Let's do stomach acid now. Same thing. Stomach acid has a pH of 1.2. So same thing, right? 1.2 equals minus log hydrogen ion concentration. The reason I'm putting in exponential, I kind of had nowhere to go, right? I have to compare these two. I think comparing in exponential form is easier than comparing in log form. So the negative 1.2 equals log of hydrogen ion. So that means that the stomach acid is 10 to the 1.2. This is stomach acid. Okay, hydrogen ion concentration. Okay, so here I've got what they wanted me to do, kinda. I haven't compared them yet. I have my acid rain stomach acid. It says, how many times greater is stomach acid than the lake? Express your answer as a whole number. Okay, so they want me to compare stomach acid to acid rain, right? They listed stomach acid first, so that's stronger than acid rain. So that means I have 10 to the negative 1.2 compared to 10 to the negative 4.4. So how many times greater is this than this? Let's see, what would you do here now? Yeah, I've got the same basis, so if I can combine them, right, what would that be? 10 to the negative 1.2 plus 4.4, right? Subtracting, so that would be 10 to the 3.6. Agreed? I think. Okay, or sorry, 3.2. 3.2. But they want me to as a whole number, right? Well, sorry, I kind of ran out of room here. It's going to move up here. 10 to the 3.2. What's 3.2 as a whole number? Let's see what that is. 1585 times as strong. So stomach acid is 1585 times stronger than a polluted lake. Again, the math wasn't hard. Would you agree? It's just taking a formula, converting it to exponential. The math is not hard at all. But would you have known what to do with that question? Probably not if you've never seen logs before, right? It's just knowing what they want, right? How to set it up, what they want. The actual math is super easy, right? Like base 10, you subtract exponents, that's grade 10 stuff. But the setup is the grade 12 stuff, right? Okay, I think I've talked enough. I was going to finish, but I've talked enough today. So I'm going to give you a few things to look at. We'll do these two tomorrow. Of course, if you want it at home, you can try these, and I'll do these tomorrow. What I'd like you to do is, there's quite a bit in this book, which is nice for this chapter. There's lots and lots for you to review. You can start exercises 7.7. Now, it's not quite as nice as doing it with me because I was giving you the formulas, and really, you should have been given the formulas. But like I say, you can just flip back to the examples or to the examples we did today for some formulas. Pay attention because number 2, it doesn't say it, but number 2 is a multiple choice. So you might be a little confused by that. Number 2 is multiple choice, and so is number 6 is multiple choice. So I would suggest there are 13 questions. I mean, try, get it on it, do as much as you can. The other thing that I like about this book is then to set you up for the test, they have practice tests like they always do. But before the practice test, there's questions without a calculator, which are really good, so you can just play around. So if you get bored with your word problems, you can also start on questions without a calculator, okay? So there's lots for you to do to get ready for Monday. But start doing some word problems. Well, actually, you know what? I think number is a multiple choice too. So 2, 4, and 6 are all multiple choice, right? Okay, I'll give you a bit of work time now and time to ask me questions if you need to.